Hello and welcome to the Artemis Learning Series. My name is Lucia Iglesias, and today we're talking about immersive storytelling, experimentation, and multiscale modeling approaches. VR is often associated with entertainment, think video games, for instance. However, it is becoming a tool for scientific research as well. Exploration, widening our understanding and interpretation of complex matters, regarding the multi-scale modeling, these complex matters, systems, and like apparatus are better understood, not only looking at the thing as a whole, but also accounting for and navigating from the atoms or cells that make them up to its wider spatial context. So let's start by taking a look at what we mean by immersive storytelling and its applications on scientific research and data interpretation. When you're working with extensive data sets, usually you look at them on your desktop. In a VR environment, you can find yourself inside the information and the data. The data is embodied in your surroundings. Our brains are wired to interpret a space in 3D. This also applies when understanding spatial information in contexts such as research, urban planning, or very small scale examples like bodily functions, molecules, cells, and so on. If we were to visualize a human cell on a contextualized but bigger scale, we would be able to detect patterns, peculiarities, and other aspects that could probably go unnoticed on an Excel sheet. We can consider also decision making scenarios. Having a committee of experts debate, explore, and make decisions as if they were on site gives an insight on the situation that otherwise would not be possible. For example, think of an evaluation that is immersive of an electrical system or a light system inside of a cathedral. We would have a committee of experts testing out different systems, different ways to set the lights, see how they affect, how they create shadows, what place do we need to illuminate better, and so on, without actually setting anything in stone. We would be able to test those things out first, immersively, of course. Um, there are many formats of visualizing digital twins. We have the desktop format, which is useful for like quick diagnosis and data analysis in an easy to access context. It also supports mapping data to visual representations such as 3D models, but with the limitation of a format that lacks spatial context. On the other hand, the immersive formats do not have this limitation and give more visually appealing, scaled representations of datasets. It also makes it more intuitive when it comes to simulating, experimenting, and interacting with the model, as well as to integrate semantic data in it. I think this is easier understood if we were to take a look at a use case. So let's watch this short clip that portrays how we can use immersive storytelling with a multi-scale approach. Bear in mind that it's immersive 360 degrees content, so what we're seeing is a flat version of it. In that video, we could see a clear example of how we can immersively travel from a bigger scale where we see the vineyard from above, from within, and then jump inside the tree and see the biological processes that are taking place in its vascular system, for example. A use case like this one can have applicability in contexts such as education for showing biological processes and understanding them better, also for agriculture and assessing the conditions of the field or of the crop. If we were to map the model towards the digital twin, where we get real time updates on the state of all of it, and also for experimentation and simulation to test different actions and prevent damages. But now I want to bring this closer to the Artemis scope and the heritage field. So let's take a look at the short video of another use case. This one is a reconstruction of an archaeological site in a specific time. As you can see, this is a pretty effective way of interpreting archaeological remains and a clear example of immersive spatial reconstruction. It is a pretty useful solution when, in cases like this, it is modeled by professionals, and with the guidance of scientists and archaeologists that ensured a certain degree of truthfulness, at least according to scientific research. It is actually a tool for further research, as it can help validate methodologies and hypotheses that researchers may formulate. Um, it also helps contextualizing the remains and the site, providing a new kind of insight on different factors that otherwise could be difficult to account for as they wouldn't be scaled. Moreover, having semantic data that is available and is mapped in the model helps expand this insight and with it the research possibility that it presents. I want to go into collaboration now, which is another key aspect that Artemis fosters in these environments. It's about creating a common workspace and with it a different way of conducting research and evaluations. This collaboration can take different shapes and forms, including spatial audio and physical representation of other colleagues or users in the immersive workspace. This can also be achieved either through avatars or other solutions, such as real-time streamings that allow you to see your colleagues. On the other hand, collaboration models can change according to the specific needs of each use case, but can support a multi-user approach where everyone is accessing and working on the same data simultaneously, as well as synchronizing the data to get real-life updates on the datasets or the activity of other users. Take, for instance, a collaborative workspace for conducting damage evaluation or going over restoration strategies on a heritage site. We could have a group of experts looking and interacting with the model of the asset that can be mapped to its digital twin, getting the data in real time. And this scenario brings up a lot of possibilities for bringing professionals together, for experimenting, for simulating, and taking actions with a higher success rate. The immersive quality accounts for the scaled context and therefore makes more variables visible to the users. Take, for example, the effect of the shadow of a tree nearby over a specific site. So, to kind of finish up and sum up, the immersive technology is not a visual luxury, but rather a useful tool for understanding complex scenarios, situation, and context. It's useful for research, for scientific study, for education. In this case, space becomes a language itself for interpreting from the inside of a plan to the urban configuration of a whole city. So, thank you for your time.